In this video, we're going to look at how to convert a slope-intercept equation to a standard form equation when it has rational numbers. In other words, when it has fractions. So let's take a look at this problem real quick. For instance, my slope-intercept form happens to be in this problem. Y is equal to 1 over 9 x minus 5 over 3. Now, we want to go ahead and we want to convert this. So there's a couple things that we got to do in order to accomplish that. So first, step one, I'm going to write it out as we do it, is I want you to multiply the denominators. In other words, we have a 9 and we have a 3, right? They're different denominators. That makes this problem, in my opinion, a little bit more challenging. And so we're going to multiply those out. We want to find what their product is. So the product of 3 and 9, if we multiply them, is going to be 27. We're going to use this number in step 2. But step 1 is we just simply look at our denominators and we multiply them out. So I'm going to move this up just a little bit. And let's go ahead and go to step 2 now. So step 2, we're going to go ahead and multiply the answer from step 1 to both sides of the equation. Now, if I'm going to do that, I'm going to go ahead and say, well, we got 27. So now that I finished that, I'm going to rewrite this equation right here. I have y equals 1 over 9x minus 5 over 3. And if I want to multiply it to both sides, the best way to address the right side, because we have two different terms, is to put them in parentheses to make sure that we don't forget to multiply the 27 to both of those terms. So I'm going to go ahead and put 27 over here in parentheses because we're going to be multiplying it. And then go ahead and multiply the left side of the equation by 27 as well. Because remember, anytime we're doing work with an equation, we always want to keep things balanced. Whatever we do to the right, we got to do to the left. Now, the one on the left is really simple, right? Because 27 times y is just going to give me 27y. And now comes some work because we got to multiply these fractions out. But the thing is, you don't have to worry about it because we can just use our calculator. So I'm going to get my calculator, and we are going to take this 27 right here, and we're going to multiply it to 1 over 9. So I'm going to take that 27, and actually let me rephrase that. Let me go ahead and put my alpha y equals. Let's get our fraction in there. I'm going to do 1 over 9, and then I'm going to go ahead and put a parenthesis and put 27 in it because we're multiplying it by 27. And it gives me 3. So I'm just going to write the answer right underneath it. So this gives me 3x. Now we're going to take that 27 and we're going to multiply it to the next fractional value, right? The next rational number. And it's going to be this negative 5 over 3. And don't forget to keep that sign with the number. So let me hit alpha y equals enter to get my fraction bar. And I'll do negative 5 over 3 and multiply that to 27. And it gives me negative 45. So I'm going to write that answer right there. There's my constant. And now that we've got this done, we're ready to go ahead and go to our next step. So I'm going to move my calculator back out of the way. We've done step 1. Right? We multiplied the two denominators together, the 9 and the 3. That gave us 27. Step 2, we multiplied the answer from step 1 to both sides of the equation. So we took that answer, 27, multiplied it to the y, and we multiplied it to both terms on the right side of the equation. So I'm going to move this down just a little bit. So just bear with me. And now I'm going to write step 3. In step 3, before we go any further, we want to go ahead and we want to find a greatest common factor. We want to know, is there a greatest common factor that exists somewhere inside of here. Now we don't know, but you may not be able to tell by looking at it, but usually what I do is I find the lowest number, the smallest number that we have in here, and then I see, can that number go into all three terms? And I'll test it before I actually use it. So for instance, I have a 3, right? 3 is going to be my largest, let me rephrase it, my smallest value. And so I'm going to see, can 3 go into 27? So I'm going to do 27 divided by 3. And notice it gives me 9. And I know 3 can go into 3, right? Because any number divided by itself is just 1. And then I'm going to see, can 3 go into negative 45? So negative 45 divided by 3. And it does. It goes in 15 times. So since 3 can go into all these numbers, I'm actually going to divide every one of these numbers by 3 because 3 is my greatest common factor. And it's been, you haven't probably dealt with greatest common factor since 7th grade, but now you're going to use it again. And let's go ahead and convert all these. Now, I already did the calculations. When I divided 27 by 3, according to my calculator, it gave me 9. So that left me with 9 y's. And 3 going to 3 one time, so that simply left me with 1x. And we said 3 can go into negative 45, negative 15 times. So now I have much smaller numbers that are more manageable, easier to work with, and this is a necessary step. Now for those of you who are wondering, well, what if we tried dividing out our greatest common factor, or we tried to find a greatest common factor, and there was nothing that would go into all three terms? In other words, we couldn't find a single number that could go into 27, 3, and 45 to further simplify it. Well, if you couldn't find one, then you just continue to the next step. So the only time that there's going to be a change here is if you find a number that can go into all three of these terms. Now step 3, we're going to go ahead and we're going to make some adjustments. What we want to do now is we want to go ahead and we want to move this 1x, right? Because this doesn't look like standard form, because our standard form, if I go back up here, has ax plus by equals c. In other words, the x and the y are both on the same side of the equation. And notice in this particular problem, our x is on the opposite side. So we are going to need to move it. So for step 3, I'm going to go ahead and put on there, move x left to be with y. So we're going to get them together. Now to go ahead and do that, I know this is a positive 1x, so if I want to move it over to the left side of the equation, I'm going to do the inverse operation, which is subtract 1x. Now if I subtract them, right, these will cancel out. I'm then going to go ahead and subtract 1x from the left side. Now while you might be tempted to combine these terms, you can't, because one has a y variable and one has an x. So we're simply going to rewrite them with the x going first. In other words, this is going to turn into negative 1x. Now notice this time I didn't put the 1 in front of it, and that's just because the 1 is not necessary, right? There's always an invisible 1 in front of every variable. So we can just put negative x, which means negative 1x. And then the 9y, all I'm going to do is just bring it down and put it right after the x. Now that's a positive 9y, so I'm going to put plus 9y. And this is equal to, and then we're going to bring down our constant value, negative 15. Now if you're writing this down to have notes so that you can do this yourself, I would note that right here with these 3's where I divided out, I didn't put that as a step, but we are going to take out our greatest common factor. So I'm just going to write that as a side note, right? You don't always have to take out a greatest common factor, so I'm not putting that as a step, but you do need to check to see if you can. If you can, you take it out. If you can't, you just go ahead and continue to the next step, which step 3 is, we're just going to move that x to the left. So notice we've accomplished that. We move the x over to the left, and now I have my final answer. Now, for some of you who are looking at this going, you know what, Mr. H, how do I know for sure that this is correct, that this is it in standard form? Well, if you wanted to check your work, you could always go ahead and convert this back to slope-intercept form, which in my opinion is easier than converting it from slope-intercept form to standard form. So let me show you what I mean. If I wanted to check my answer, I know that the original equation we were given was y is equal to 1 over 9x minus 5 over 3. So knowing that this is the equation I should have, if I convert this one right here back, I can go ahead and try that and see, do I get it? So for instance, I have negative x plus 9y. And this is just how you would check your work. So I would add x to both sides. So plus x. I'm going to draw my line here. Now I know all of you have had plenty of practice doing these where we convert them from standard to slope-intercept. That's the most common thing to be done. And so we're going to put 9y. And now we have a negative 15 and x. We can't put them together, so we simply write x, and the negative 15 comes down beside it. So minus 15. The next thing I'll do is I'll divide by my coefficient, which happens to be 9. And I would do that with all three terms. And this ends up being, let me move it down just a little bit more. 9 over 9 one time leaves me with y is equal to, and notice right there is that invisible 1 that's in front of the x. So this actually becomes 1 over 9x. 1 over 9x. And then if I have negative 15 over 9, my calculator can actually simplify that fraction for me. If you're not good at simplifying them, I just recommend putting them in a calculator. And so let me go ahead and put negative 15 over 9. And let's see if it changes it. And it does. It changes it to negative 5 over 3. So what I want you to notice is, I know I did it right, because when I took what I converted to standard form, if I convert it back to slope-intercept form, it matches. So this is how you would check your work. But if you feel confident you got it after doing the process that I just showed, those 3 steps, multiplying the denominators, multiplying that answer to both sides of the equation, removing your greatest common factor, and then moving the x over, well then you can just go ahead and proceed with it. But if you want to check it, right, you can always convert it back from where you started.